Alright, kia ora. I just wanted to give an answer to the CPR quiz for this week. What did I have to say about this? This is task number 2 for week number 8 of remote learning. I won't go through this too long because I think this is mostly self-explanatory on the marking schedule. I'm just going to help you kind of process some key things. So what they've done here is that they've given you propanol, which is an aldehyde, and it's formed from the oxidation of a primary alcohol. The first bit here is they want you to draw the structure of that primary alcohol. And the main component of this question, and the reason why I've selected it, is because it asks you to explain distillation and why we use it. So draw your primary alcohol in the box, and then you have your typed up answer explaining the process of distillation. And this is a really common question this year, asking you why you do certain techniques. So we'll look over at the marking schedule. I've taken this CPR quiz from 2 different exams. So keep in mind that first question was in 2019 number A, or 1A. It should be. Yep, so this one is the aldehyde can be oxidized to carboxylic. I don't think I'm looking at the right thing. Hold on. Propanol, question 1, part 2. Right. No, that's the right one. So yeah, it's just saying that aldehydes can be oxidized to carboxylic acids. We need to remove it before that happens, and that's what distillation is doing. The main thing that you really need to stress with that distillation is that boiling point. That's the whole thing that makes it unique and special, and that aldehydes have a lower boiling point. Right now, this question only goes up to the merit level of a point. I have seen stuff like that go up to the excellence. It really just depends on what else is in the format of that question. The thing that I would say you could do to kind of give yourself that extra cushion to make sure you know, just in case it does go up to an excellence point, is just being really clear why the aldehydes have the lowest boiling point. And that has to do with the fact that when you compare it to an alcohol or even the water that's mixed into solution, it has only the weak intermolecular forces. There is no more hydrogen bonds, and hydrogen bonds are the strongest of the intermolecular forces and require more energy to break, thus a higher melting point and boiling point. So since the aldehydes lack it, it doesn't require as much energy to break it, so that's the lower boiling point in comparison to the other things in solution. It's a good, useful thing to add because every so often, like I said, that extra detail would be what they might want for an excellence, but it depends. Sometimes they have the excellence point there, sometimes they don't. So it's up to you if you want to take the time to write that answer. All right, second one here is, again, a question I love. I love these conversion questions because it really tests to see if you know what's going on. So what we see here is a butanol. The aldehyde's on carbon number 1, and they want you to convert the butanol to a butanone. The good news is that the moment we get it on carbon number 2, it's a butanone, and there's only one butanone because if you get it onto carbon number 3, it's still butanone. So again, it's very similar to the one that I did in the lesson notes, where you're trying to do some sort of conversion from one thing to another. And in this case, you have to think about, okay, what do I need stepwise to get from A to B? I suggest don't answer this necessarily in order, especially if you're stuck. If you are stuck and you don't know what to do things that are logical. So with an aldehyde, I need to reverse it. There is no forward spot to an aldehyde. The only thing that it goes forward to is a carboxylic acid, and when you know your flow chart, you know a carboxylic acid is a dead end. So you need to go backwards. And so show the reduction of the aldehyde to a alcohol. That really helps. You could also look at the butanone end of the question. In order to form a ketone, what do I need to do? I need to have a secondary alcohol. So just show that step, secondary alcohol getting oxidized to the ketone. Now, does that link the whole chain together? No, but it gives you 2 components of the chain. And those 2 components of the chain can give you some points, maybe an achieved maybe a merit. So let's look at this marking schedule. And this one was from 2018. And it was question 3 that we're looking at. And you'll see with question 3 what I mean. hopefully. Maybe it was actually question 2. And I just wrote the wrong thing down. It is question 2B. I think I wrote the wrong thing down. That's question C, and that's question C2, and I've written question C2, so I've just written the wrong thing here. No, I can't fix that because that's my website. That's not the editing view. That's fine. I'll fix it for you guys so it doesn't look funky. And it makes more sense. Okay. So what you can see here, we've done the reversal of the reaction, the reduction back to the alcohol, and we can see in this final step here that you can have the alcohol going to the ketone. Now, fun fact, like I said, when in doubt, try to get to the alkene because the alkene is the intermediate steps for getting things shifted around. So if I have an alkene there and then I break the alkene, I can add stuff to it. Now, what we're going to be doing is adding the water. So it's going to be a hydration reaction. But in this case, we have that major minor. So even though they're not going to ask you to explain major minor as a full justification at level 3, you still need to be able to use it because you're going to need to be able to state, I want to take the major product. Because butane 1-ol and butane 2-ol will be produced, but I want butane 2-ol because I want to oxidize that to the butane 2 or butanone. So just keep that in mind. Make sure that you have all the reagents needed. Make sure you state any observations that you would occur. And as you can see with this marking schedule, look at how little is there because so little is explained, like that there's so little like explanation you need. It's basically judging you on can you get that conversion correct. So the excellence, devise a reaction scheme with all appropriate reagents, with all conditions, with all products. So if you can do this whole thing, don't need to write any justification explaining why, don't need to explain Makarnikov's rule or Zaytev's rule or anything like that. You get that excellence point. It's a really easy excellence point, and you'll see that throughout organic chemistry that a lot of these points are quite easy if you know what you're doing. For the merit, it's just a workable scheme with correct steps that would produce butene, but there's 3 correct structures. It's probably just something in there that's a little bit meh and wrong. And then for the achieved, you identify one reagent step, name of the product of the formula of the reaction, or a workable sequence with 2 correct structures. So it's kind of like that iffy zone of you've done something wrong. But like I said, you could have this first step and this last step, and that would be sufficient enough to get you an achieved, I believe. The problem with this sort of question, and I said that last time in the CPR quiz, is that it's basically either achieved or excellence. It's very hard to kind of get merits in some of these because you either know what you're doing or you don't know what you're doing. And so if you don't know what you're doing, I want to make sure you know enough to scrape by to get your achieves. All right, cool. That's that question there. So I hope that kind of model walkthrough helps that make a little bit more sense, and I'll fix the little typos on my website. All right, cool. That's it. Open up the wrong thing.